All right, hello everybody. We are with the AI aided expander machine parameter optimization team, and we are representing TE. I am the team lead, Yakub. There is Anton, Izzy, Yakun, Eddie, and Yuchen. We are all majoring in ECE. Our university advisor is Alex Mamachev, and our TE advisors are Pablo, Mulong, and Joseph. So the automation manufacturing technology team at TE aims to automate parameter adjustments for a medical manufacturing machine using a closed loop system with the assistance from a machine learning model. The project automates parameter adjustments for a medical manufacturing machine using this closed loop system, specifically with the use of a machine learning model that automates everything and adjusts according to various tuning parameters. The current method for machine tuning in our process generates approximately 20% scrap material due to the initial setup required to achieve the correct outer and inner diameters within the needed specification. For the approach, we plan to receive data pertaining to desired air pressure, including features such as outer diameter, surface quality, and processed product length. We plan to pre-process the data by eliminating redundant entries, integrating data sets, and conducting exploratory analysis on essential parameters within the machine learning framework. We plan to create an AI model that achieves a baseline accuracy of 70% upon initial deployment and exhibits capability for accuracy enhancement through iterative development. We plan to validate the model's predictive performance against the industry standard CPK metric, ensuring it meets a threshold of about 1.3 for robustness and reliability. We also plan to integrate a real-time prediction deployment through a website for seamless user interaction and a dynamic response based on live data inputs. The primary objective of this model is to assist with fine-tuning parameters to enable precise control over the tube outer diameter specifications, and this can be done through several tuning parameters, as you can see here, such as material feeding systems, temperature control systems, pressure control systems, expanding system, and product quality evaluation systems. So the machine learning model will learn from the current operational practices and find the best values. On the first stage of operation, we will use that information to operate the machine. On the second stage, and with a more mature model, we will use that data to feed back directly into the machine, making it significantly better and able to robustly provide a complete and optimized output.
Yeah, to solve this problem, we have to take several approaches. First is we gather data from the operators themselves, and we go through the machine learning pipeline, such as data preprocessing and the machine learning model development, where we create a model and we try to hit the baseline accuracy of more than 70%. We also calculate the CPK metrics for process quality control, and we also target it with threshold of 1.3 for reliability. We also developed a real-time web page where we visualize the model's performance and the CPK metrics. So data pre-processing is one of the first pipelines in machine learning model development. This is where we gather the type of data and we turn them into CSV files. Uh, and we go through all the data cleaning techniques, such as we identify outliers and we handle the missing data. We go through the feature selection and we prepare this filtered data to develop the machine learning model. Next slide.
Okay, for model development, we have joined many model like linear, logistic, decision tree, random forest, ONN, FNN. From experience step, we do feature selecting, which mean we selecting their important feature and then do data splitting into like training, testing, validation, and then we have tried many like, data set from the data given from uh, mentor. Also, so for overall, we decided to choose TUI model. With TUI model, we have highest accuracy, like decision tree, random forest, and RNN. Uh, in this TUI model, we have tried model improvement. In the beginning, we got like 61% for decision tree, and then for technique, we're using like to choose like pass side or edit the max step, and then we got like 97% are for the same technique. We did the same to random forest and RNN, and the model improvement to 98% for random forest and 96% for RNN. Next slide, please. Okay, as you can see, the actual and predictive value for two model we have here, decision tree, random forest. For decision tree, we have we got 97% accuracy, and you can see like the predictive really good compared to actual value. Also like 98% for random forest, the predictive value almost like fits actual value here. Okay, next slide.
So we choose an LSTM model for three key reasons. First, our data is sequential, and it's making it crucial to capture the context of each event over time. And secondly, our prediction rely heavily on the previous data, which LSTM handle well by learning from the dependency in the data. And finally, our complex and large dataset benefits from the LSTM ability to remember important information from earlier in the sequential. And the right-hand side is the LSTM workflow diagram. It's just briefly showing how the LSTM works and finally output the product quality prediction. Next slide, please. And you can see our LSTM showing a very outstanding predict accuracy and efficiencies, and the MSE and MAE are both very low. So it just indicates that the model prediction are highly precise and closely match the actual points showing on the right hand side. And additionally, the R-square value is very high, showing that our model explains a significant portions of the variance in the dataset. Next slide, please.
We also have a AI model visualization platform, which is a website. The website is divided into three parts: client, the server, and machine. And for the Streamlit server, it will interact with MySQL database, the machine learning model, and the cache. For the features of the system, we have CPK access, real-time predicted results, training versus validation data, and module evaluation matrix. Next slide. This is a brief video demo of our platform. So this is the first page. There are some instructions for the new users. And for the left side, there's a bar in which you can select the different model you want to use to see the prediction result. So we select the random forest model. There are 4 diagrams, and they are displayed in real time. For the top 2 diagrams, they are actual value versus predicted value. And for the last 2 diagrams, it shows the CPK fluctuation and the random forest evaluation matrix.
The AI can generate creative designs and solutions based on input parameters and objectives. It can explore a wide range of possibilities that human designers might overlook and optimize designs and processes by analyzing data, identifying patterns, and recommending improvements. So in conclusion, this project can lead to more efficient and cost-effective outcomes, which increases business values and benefits to industry. And that's all about our project. Thank you.